slide?
Yeah, it's Google. So we've got 4 speakers in this session going to talk about how to build and use CORD. And as a way of introduction, how many of you are on the CORD Slack team? Okay, then these guys need no introduction. These are the names you'll see flying by because they're busy building, debugging, and oh, Ali's got different slides. No?
Hopefully it's the same slide, otherwise we're real in trouble.
Yeah.
Okay, good. As they go, I think it's one deck, right?
Yes.
All right, so as they go through it, it's as we transition, it says questions. I think what we've decided to do is skip right past that to the next talk, and then we will have them all come back up at the end and do some questions at the end. So you've met Ali. David Bainbridge is a partner from Sienna, and the 2 of them are going to describe the first stage, which is how to build.
Power on.
You can also just talk it.
All right, well, testing. Hey, cool.
Yeah. So hi, I'm Ali. You've seen me just a few minutes ago. This time I have more time, so that's cool. And this is David Bainbridge from Sienna. So we're going to talk about how we take CORD, if you were to download CORD, what you get, and what you would, how you would end up building it. So in CORD, there are 3 types of automation. There's a deployment automation, which allows you to stand up CORD. And the focus we've had here was to give you a repeatable environment, which is consistent and always kind of tries to use the same software versions of all the packages that we use. So you get a consistent experience across different environments that you may deploy CORD on. We've also done this for our own good, so that when we are on the mailing list trying to help you guys debug whatever problems you run into, we kind of know where you're headed, right? Because otherwise it's a free-for-all. We'd have no idea where you are and what you're deploying on, and it'd be a nightmare for us to help you debug. The second type of automation is operational automation. The ability to scale up and down different services in CORD as they are plugged in. And each component in CORD is seen as replaceable. We're not quite at the stage where we can just rip out something and put a new one in. We're getting there. It's going to take a bit more time, but it's getting where we've set up our deployment and our automation such that we're well set to do that. And finally, test automation. At the end of building different phases of CORD, you should be able to test it to see whether things are working and going on correctly.
All right. When we looked at CORD, we looked at different roles servers play in that and different roles they take on. So we have kind of that base level, the base level compute node, right? And on that, we saw some base level services, and I'll talk about software service layering on the next slide. But when we identified CORD, we said, okay, what are the key roles that we care about? And some were already called out, the head node. The head node is kind of what drives the rest of the CORD pod. And so when we look at automation, that determines which software is running there in terms of XOS, in terms of what we're doing in the middle as a service software. Now we got the storage nodes, which aren't actually a physical node now, but we think in the future, when we look at CORD pods as they expand out and get into production, we're going to see nodes dedicated to storage. So whether that's state for VNFs or whether that's business storage, up for grabs, but we believe that there's going to be that segmentation. And then we got the compute node. Compute node, which we're using today, is a place to run VNFs, whether those are Docker container VNFs, whether those are virtual machine VNFs. Essentially is a compute area. And in this slide here, we've even broken that out and said, look, we have a compute node, and we're going to focus that in Docker containers. But we also have this other node, this V node, and we wanted to segment that out specially for VMs, for VMs. And so as we go through and look at CORD and get more experience with deployments, we're going to try to focus these roles and say, okay, what roles make sense? Do we need to add more roles? Now, in smaller deployments, what we'll see is combination roles. One server will play many roles. And this is important just because when we build out our software and our automation around that software, we want to keep this in mind that we're role-based. So I can take any given hardware and apply different roles to it and say, you are this role. And that can help us in troubleshooting. That can help us in scale out of different services as well. And so that's kind of the philosophy that we're using around this. And then you come out with base hardware and then just put these roles or assign these roles to this hardware and get that automated deployment software layers out on them. If I don't. So we talked about software layers. all the nodes in a CORD pod, from our perspective, are identical in terms of base hardware, right? They all have some certain characteristics that we expect with them. They'll have 40 gig interfaces for fabric interfaces. They'll have management network that they'll be connected into. Then on top of that, we start layering software depending on what role this server will have. Now, basically, we're going to need some core or base software on all the nodes. Again, I referenced Docker. So Docker is I'm a big container guy. Docker base layer is going to be there. The operating system, some Docker capability, Docker Compose capability. Then we get some higher level things, right, on top of this. And we talked about the head end. We're going to deploy Exos over there. We're going to deploy a Pixie server so that we can boot from a head end. We can boot the rest of the pod. So it becomes a self-contained unit, essentially. And then we layer on top of that storage capabilities on some nodes so that they can do distributed storage, so that they can do persistence. And then OpenStack layers, other layers if they come up. I'd have to go look at my slide to get them all down. But the idea here is that, again, generic hardware, roles assigned to that generic hardware, then depending on what role that hardware has, depends on how and what software we layer on top of that.
So something bad happened to the slide, but most of the text is there. That's a PowerPoint for you. So the idea, when you download all the software, you download one repo. CORD is essentially made up of multiple repos, but you download only one. And in that repo, you build yourself a Vagrant box, which is the development or the build environment that's on your local machine. And then on that node, you're going to build all the packages that you need, that you want to download from the internet, whatever you need to deploy CORD. It's all scripted up for you, and everything is downloaded onto that environment. And then the artifacts that you've built on your local machine are published to what is the kind of temporary head node that's in CORD. And so basically, Docker artifacts are pushed to a Docker registry, Maven artifacts to a Maven repo, software packages are pushed to an apt repo, and all of these are consistent with the version of that particular release. So we have, again, that consistent deployment environment just to make sure that you get the right stuff. And then eventually, once you bring up the pod and you turn on all the, provide electrons to all the different devices that you have, they boot up and they all get primed from that temporary head node, and they boot up from that temporary head node, which means that basically you do not need an internet connection for your CORD pod itself. You only need this priming phase that's on your local laptop, which hopefully has all the connectivity you need, and then you take that laptop and then you can deploy it onto your pod. So when you get CORD, you get also a wiring diagram that explains how you should wire things, best practices for wiring stuff. I'm not going to kind of go through the diagram because it's boring, but basically the idea is that
I drew that.
Huh?
I drew that.
I know, but you did a wonderful job. But you want to go ahead? No. But yeah. So the idea is you wire it up in this kind of consistent way. Obviously, you don't have to wire it up in any way that we prescribe, but then you have to be consistent in your configuration to be able to replicate this setup. Right? So then, once you've got everything wired up correctly, these 9 steps will automatically provide you a CORD pod, right? Hopefully. So you would clone the repo, obviously clone the CORD repo, and then you go through a set of Gradle steps. You fetch the images for Docker, the images we use, like Nginx, like ONOS, like a console, all these kind of things. And then you start building other images, like for example, our Maven repo that gets fed into the CORD pod is a Docker image itself. And then we start seeding the head node and start publishing all our artifacts into the head node. At that point, we start now building the Pixie environment and the boot environment for all the other elements for the compute nodes, as well as the switches that we have. So we start seeding that environment. We use a service made by Canonical called Metal as a Service that provides this. And then we deploy XOS, and then we start turning up equipment, compute nodes, switches, and they all boot up off this equipment, and they're taken through a kind of automation process which takes them from 0, where they have nothing on them, to completely installed, configured correctly, and ready for operation within CORD. There's one more step behind that, which is the verification phase, which is not quite fully yet integrated. Hopefully, as time goes on, this will be fully integrated, because this is something that we want to do moving forward. And the idea is that, as well for us, on a nightly basis, these steps would be done in an automated way in our lab, so that we can verify that everything we've done in CORD, and as we add code and add components to CORD, we're still doing it and everything still works, right? So this is kind of part of the continuous integration that we're bringing into CORD. So as a nightly process, our dev environment will be flashed and reinstalled every night and retested every night. So for the people who've been paying attention, you've noticed that like our previous title has a little asterisk in it. You can't see it on that slide, but you can see it on that slide. And that's because there's still some manual steps involved. So for configuring certain parts of CORD, you still need to apply some manual steps. The virtual tenant networking needs a few manual steps, and that's because we have compute nodes that have been assigned IP addresses that need to be advertised inside the VTN service. The configuration of Fabric is also a little bit manual. There's a helper there, but it only provides a partial configuration, not the entire configuration. The access devices and the vRouter are also manual steps. That kind of makes sense because we don't really know what access devices you're going to use. So we don't know. We can't tell you exactly how to attach your access device because we have no idea which one you're going to be using. And same thing goes for vRouter. We have support for OSPF and BGP, but you might be using some completely different upstream protocol, so we can't really tell you. We have documentation to tell you how to go through these phases and how you should do this, but we don't tell you the full detail of taking you from a bare vRouter config to connecting it up to your infrastructure.
So what Ollie just kind of covered was some of that initial automation to get the pod up and running. Behind that were some basic tools. So we use Gradle essentially to orchestrate it, but behind it are things that everybody would use from an IT organization: Git, Ansible, and Docker. So very basic tools. So we have the Gradle to help you along, but you can also go dig down and actually see the specific commands that are being executed against your hardware, against your pod. The other type of automation that Ollie mentioned in the first slide was kind of this operational automation. The vision here is really that we want to have a pod where I can add a compute node and it'll become part of the pod. I can have a failed switch, pull it out, put a new one in, and it'll become part of the fabric. And so behind that, there are some microservice network, if you will, of automation tools to help that along. And we're actually using that today to even to boot the initial pod. So in that last step, or one of the last steps where it said power on your equipment, give it electrons, this automation is being used to bring on those compute nodes, those extra compute nodes today, as well as the switches. So on top of this was MAS, which is Metal as a Service by Canonical. It provides Pixie services, but it's a very manual process today, which means things come up into MAS and I have to go to the UI and click and click and click. And we've essentially automated that through a microservice, this automation microservice. Is there a pointer? Which button? Which one do I push though? The middle. That wouldn't be it though, would it?
No, what have you done?
I broke it. I broke Google. Who can say that?
There.
Thank you. Okay. Which one? The middle button?
Yeah.
No, that didn't work either. Anyway,
All right, well.
Everybody can read the word automation. So there's a microservice there that essentially works with MAS, looks at the nodes that MAS has discovered up through the Pixie boot process, and walks them through the life cycle of hardware deployment, of compute node deployment. And once it gets to the end of the MAS cycle, it actually then starts doing core deployment capabilities. So in terms of what we have today, enrolls it in XOS, so it can be an XOS node, throws the base levels that we talked about. Again, it builds on that layering software model that we talked about before. Along with that, we have other helpers in there. We have like a DHCP harvester. MAS, in the current version we're using, doesn't do DDNS quite as well as we want on all the nodes. So we have to help it along. So some of these microservices we're using today, but as we go forward and get newer versions of software, MAS, they may change, they may go away, and we expect that. Again, that's how a microservice environment can work. Other important things that we notice are the provisioner here. The provisioner really is the piece of software that says when I have a new compute node or when I have a new switch, what do I do to it? And it goes off and it runs the scripts to layer the software on top of it. Now, we alluded to also a config generation for the fabric that we have kind of working today. What I mean by that is it can actually generate a config, and that fabric config will work on your fabric. In fact, I did it this morning. It's just not completely automated into the cycle, which means when we get the switches all into all into CORD, and we get all the compute nodes into CORD, we don't have the triggers that say, hey, go generate a config, and then, by the way, go push it at Onos so that we can have a fabric up and running. We're getting there. It's just not that automation. The important thing I think we'll see as we go forward in automation is more of these microservices on a need basis that will come into play, and they'll be tweaked, as I said before. I think I'll leave it at that. We also mentioned test automation. And in the first slide, we talked about test automation or nightly build, which is absolutely what we want to do. We want to be able to build the software. We want to be able to test it, verify that it works, and then we can call that a daily, nightly build, nightly release. On top of that, what we also want to do is be able to run tests in production. Why limit test just to development cycles? We want to be able to verify that a CORD pod is up and running all the time. In fact, we might want to actually put a chaos monkey out there and say, hey, chaos monkey, go start kicking things, and then rerun the verification to make sure the pod's still operational. This is something that I think we need in production so that any customer using this has confidence that the pod is up and running at all times. So when we looked at test, we looked at where we need to insert packets and where we needed to test the results of those packets so that we can verify the shut up phone. So they can verify that we're getting the proper responses. And as we did this, we started to say, okay, we can put a test server outside the pod. And if we did that, here's where we need to wire it in. And when we did that, what we noticed is, wow, it has basically the same connections as a compute node. So when we did this, we said, okay, what the right thing to do here is really say our tests are going to run on a compute node. It's a network virtual function. It's no different than any other function that we're going to deploy out. And this is another philosophy that we've working to adapt. Applications, NFFs, they're all the same. NVIA, whatever, NVIA, NFV. Thank you, NFVs. They're all the same. These are things that we're going to deploy, and CORD has that capability to deploy them, execute them, and look at their results. So when we look at testing, we're going to deploy those tests just like we deploy any other network function in our CORD pod. And as a customer, you can decide which tests you want to run, how often, those type of things. Eventually, not today. But we do have a test suite that has been built. It isn't fully integrated in terms of we're not doing the nightly builds. It's not kicking off automatically. We're working towards that. Right now, it's a manual process to that last step of verification. There is some documentation how to do that, but you can see a whole slew of tests. You can see that we're testing packets as data coming from the OLT through the infrastructure. We can see packets being generated by the internet coming back to the OLT. We can look at the packets running through the CORD compute nodes and making sure we're seeing chained events come through. So DHCP, DNS, all these type of packets are things that we're testing. I'm just going to skip that.
I got messed up.
What?
You got messed up.
Why?
Because there's a whole bunch missing.
There's a whole bunch missing? Yes, there are. The slides when they got put over in here. So what we have now in this slide here is a list of tests that we have implemented today. And they go on beyond the page here. So we can essentially simulate subscriber traffic. We can look at the vRouter and understand if it's operating correctly. We're looking at security. We're looking at IGMP packets and flows across the network. What we'll see, I think, is this suite of tests will increase over time. And the hope here is that as we deploy CORD in production and as we see issues with CORD in production, because we will see issues with CORD in production, we can take that and roll that back into this test suite so that we have verification at the end of the build and we have verification in operation. And again, back to the point, a customer can be confident that once CORD is deployed and in operation, through test verification, it is working.
So right now, the tests that we have are mostly testing components in CORD and not drilling down into the components, reporting on their health or anything, which eventually also is something that we would want to have. But right now, we're testing the functionality of these individual components, and we can do end-to-end tests as well.
And we'll also have to start building some troubleshooting tools,
yes,
which we do internally have processes that we use, but we don't have tools necessarily. Yeah. So as people deploy CORD and have tools that they've built, please contribute them back, because those troubleshooting tools will be key to actually successful CORD deployments in production.
All right. And I think with that, we can move on to Zach's talk.
These guys are going to stay on time. They've got work to do. All right, so the next speaker is Zach Williams, who works with me. I live in Tucson. He works at the University of Arizona. We're also a user of CORD, and we've got a deployment called OpenCloud with not central offices, but clusters at universities throughout the country where we're going to be running the CORD software. Zach is involved as a user pulling that in, but he's been contributing back. So he's a great example of the open source community giving back. And he also is an Ansible expert, which has been a really helpful thing. He's going to take you through the onboarding process.
Okay, so yeah, I'm Zach Williams. I understand the XOS side of things extremely well and how that integrates with the CORD pod. So I'm going to go over the installation process of a CORD pod. This is sort of after what David was talking about in that deploy platform Gradle section. CORD's data model is defined in XOS and is constructed using two repos, a platform install and a service profile repo. Those take a bare server with just the operating system installed and do all the processes that need to happen to get CORD installed on it. I'm going to talk about how this is accomplished and how services are composed and then onboarded into XOS. As David said, the mass way is one way of doing this. We also, for the single node scenario, which is very useful for development and testing, we have a CORD single node pod, which puts all of the different parts of CORD into one system. And we actually already have a lot of the testing that they were talking about going with this setup. This is an example of what actually lives in a single node configuration. Everything's on the head node in this case. Platform install uses Ansible to construct a CORD pod, and it does that by creating a bunch of virtual machines. Everything that's in the KVM virtualization box is a virtual machine. The XOS is put in a virtual machine. Inside that, it runs Docker. Inside that, it runs containers that handle all of the different portions of running XOS. Database, API endpoints, dynamic synchronizers, and we also run ONOS in its own virtual machine, which is also then has Docker inside and then has ONOS inside that. There are two of those for the Fabric synchronizer and for the OpenCORD apps. And we also run we're using Canonical's Juju tool to create an OpenStack installation. And there's a bunch of virtual machines that are dedicated to that. In addition, there are some other services like DNS and package caching, which live on that head node. In the multi-node scenario, it's very similar to the single node scenario, except for you'll notice that, the mass is handling DNS, and that OpenStack isn't just running only on the head node, but the compute portions of OpenStack are running on external compute nodes. We have a dynamic onboarding system using service profiles. We're a repository called Platform Install, and right after we've started bringing up XOS, you have very few Docker containers. You have a bootstrapping UI, one, a database, the OpenStack synchronizer, and an onboarding synchronizer. And what happens is you have a set of configurations in the service profile repo, and that list of services gets brought on board. And so each one of those services in the second side where it says created by onboarding synchronizer, each service is in its own repo. Those all get downloaded and installed into and they get a Docker container for their synchronizer to run in. The way that this works in XOS is a data model. The synchronizers work on the data model, so if something gets changed in the data model, the synchronizer runs and then implements and is in charge of implementing that data model change in the rest of the system. For example, the VSG synchronizer would work on VSG containers and make those changes, or ONOS would be a conduit for changes that happen in XOS to get applied to ONOS. We also have something called example service. You'll see a lot of that. That's an example service that runs just an Apache, a web server. And we have in XOS, there's a dependency graph between the different items in XOS. XOS's services are done as a Django data model. They're independent on each other. We generate a service graph. In the single node pod, this is an example. So the example service uses a network that the VSG provides. It requires for it to run its virtual machine. It needs a VM instance that's provided by OpenStack. It needs an operating system image that is installed into that instance. And the VSG also needs those same things. So we create a service graph that has of what services need things provided by other services. This shows the synchronization process. So when a change comes into the system via either the web UI, through API calls, or the TOSCA interface, they go into the XOS UI container, which provides a web interface and API endpoints. Those changes happen into the services data model, and then the synchronizers detect that those happen. In this example, let's say a new VSG and example service instances need to be created. Via the service graph, it determines that they both need virtual machines. So they go out to OpenStack Compute and they get that VSG VM instance and the example service VM instance. Those both get created because those are dependencies of the services. Then within them, the VSG synchronizer and the example synchronizer both use Ansible to install or configure the services inside the virtual machines. So they go out and install a web server and start up a Docker container. And then all of this is dependent also on ONOS having plumbed all the network into place. So the ONOS synchronizer would tell ONOS that's running in the other Docker container to configure the network switching. And then as all this comes together, we have a service that all the services are implemented. And this doesn't necessarily have to happen via Ansible. You can have it call, it's Python code. You can have it do almost anything. You can have it call APIs. You can have it talk to other services that are dependent and that sort of thing. So how are these actually made? If you have a service, we're sharing, each service is usually expressed as a Git repository. We have both. If there's an ONOS app, it's also in there, but most of the code is in the XOS directory. There's an onboarding spec which tells XOS how to bring that service on board, what things it needs, if it needs extra files, if it needs what kind of, if it needs an image, if it needs a Docker container, that sort of thing. There's a data model and an administrative GUI. Those are both done per Django. So if you're familiar with Django, you'd have a pretty good idea of how to create a data model. And it's very similar. There's some extensions that XOS has, but in general, it's very similar to what Django has. The APIs for REST and TOSCA, those are provided either in the REST case through the Django REST framework, which is sort of a best of breed REST framework. And the TOSCA API is implemented through XOS. And then we have a synchronizer. The synchronizer is that Docker container that takes the changes in the database and applies them to the actual running systems. And it can do, and it's done as a set of Ansible scripts and playbooks and Python. And then if you have an ONOS app attached to this, you'd put it in there too. And that's generally how that works. Again, we do have testing for end-to-end testing for at least the single node pod, and that is really well tested. So if you want to start on something and you have a beefy enough server, go ahead and try to run that today. Okay. Thanks.
So if you can't tell, we, not knowing any better, had the audacity to try to build a data center as a service. Lots and lots of moving parts here. The last talk is, all right, now your pod's up and running. You've onboarded the service graph that you want. Now you want to control it. We got REST APIs, we got GUIs, and Mateo's going to walk you through that. He's a user interface person, so his slides and animation are better than anyone else's as well.
Thanks, Larry. And I'm in a strange situation because everybody today was short on time. I'm plenty. I try not to bore you too much. So now we have our pod up and running, and we start interacting with this. And we have mainly 3 endpoints to manage our core infrastructure: the graphical user interface, REST APIs, and TOSCA. We normally reference all of these as UI because different users of the system can interact with the system in different ways. The graphical user interface is normally used to get some visual feedback and perform some diagnostic on the system status. REST APIs are used to integrate with other system analytics tools. We can think about having external application, customer management, and whatever. And we can use them also to perform some runtime configuration, while TOSCA is the natural entry point to define the system bootstrapping and define our service graph. Let's go a bit deeper in what is the graphical user interface. It is composed basically by 2 pieces. We refer to them as global views that are powered by the Django framework. We made these choose to let you quickly define views to operate on models and quickly define views that let you operate on services. This is more or less the structure we have in the system. We have these global views generated by Django, and then we have a set of custom views that are defined in AngularJS. The main difference between the two is that we can quickly generate these global views without caring about HTML, CSS, and styling process. But if we want some more custom for our workflow, if you want to combine more models, we provide you the ability to generate a custom views that open all the opportunities we have with the new web. As Zach talked about some minutes ago, we have a UI bootstrap container that loads all the custom views and all the core model related views. If we want, and it's quite comfortable to use that container to develop new feature in that area. If we want to work on the service view, we need to spin up a real pod. Can be the single node pod, can be just a development environment, but we need to have the full system booted and the synchronizer running to onboard the services and views. Define a service view is quite easy. We can take advantages of the Django admin framework. You can find a much better documentation on their website, but basically we have to define a Python class in which we list the field of our model we want to let the user manage. We just need to register the view in the system, and we need to configure the entry point of our service. Once our service is defined, it probably need to have more than one view. So in the TOSCA file, we use to define the entry point of our service UI. And then from that page, we can reference any page we need to access to fully manage our service. When we access the UI on a core pod, we'll probably find ourselves in first place in what we call the service grid. It is basically a list of the service that we have in the system. and that page will point us to our service entry point, and then we can navigate through all the service features. We also have these custom views we talked about briefly. They are loaded on demand. We can decide for each user which views should be available in the system and which kind of interaction a user can do on that views. For now, they are living in the XOS core, but we are working on a feature that lets you define external views that can be loaded together with a service or together with a set of service. They also take advantage of UI component library because we want the developer to focus on the service itself, not on the UI to represent it. So we try to make your workflow as easy as possible. We have defined a template generator that helps you start creating these views. It's a small Node.js application that you all can run on your local machine. It will create all the bunch of files you need to have a development environment to speed up your process. And then we'll build, also if it is a JavaScript, it is not compiled, but it will make some optimization on the views and copy it in the system in the right place. How does these views work? They live inside this folder that is not contained inside a container in the core pod, but it is a separate folder for a development purpose. It will contain the source file, development server that enables some features common in front-end development, like live reload, style checking, and various optimization. It contains an environment to automatically run tests against your view, and it can connect to different environments. So the normal development workflow is to start scratching out your view against a fake server that gives you fake data, and then test it on your own pod. But if you want to connect to different environment in your lab, this is absolutely supported. When our development is finished, we are going through this build process that will move the file in the container, and we will find a minified version of the JavaScript. All the template we have defined will be cached locally, and we'll find some optimized style sheet and cross-browser compatible. What is this UI library we have talked about? It a collection of elements that are common in the CORD environment, such as table, form, some pie chart, bar chart, and there are also some classes that help you interacting with the backend and manage your data, publish user real-time notification on the browser, and this kind of stuff. What are the advantages of this? Is that this library is fully tested, and we have the same code shared around multiple views. So you can focus on the feature you want to bring to the user instead of the development process. You can find more documentation online on the wiki. The second entry point we talked about are the REST API. They, of course, follow all the REST principles. They talk in JSON, and they use HTTP status to give you the response. And they are organized in 4 main categories. Core, related, of course, to the core model. Utility is all a set of helpers that are not necessarily related to a model, but it's useful to manage the system. In there, we have endpoint like login, logout, load a GTOSCA recipe, and get the status of a service, the status of the onboarding synchronizer, this kind of information. Then we have 2 groups that are strictly service-related, that are service and tenant, and they get populated by the API provided by our services. All the documentation of the API is written in a blueprint format. It's basically a variant of Markdown, and it is published on API. It's an open source project, and we choose that way so that we can have a living documentation also without having a real server running. So everybody can look at it anytime, and if you're starting to work on a view, you can use it as a fake backend for your development. We have moved forward to that because having the documentation not automatically generated from the code can lead to an outdated documentation soon. So we are using the documentation to generate automatic tests against the API. This gives us the guarantee that the documentation is up to date, and every time we add an API, it works. We also provide some usage example. There is a folder that contains a series of bash scripts that perform basic pull request to CUR request to the API. And you can find also a lot of example going across the custom views we have defined, or the integration with other services like the ONOSs. Last part of the UI we use to interact with is TOSCA. We use it to describe the data model when we load the system. We use it to describe how a service should be onboarded in the system, and we use it to define the service chain dependencies. It can be loaded in the system through a dedicated REST endpoint. I nominated it before under the utility. And to make a full loop out of it, once you have a pod up and running, you can configure things across the UI or the REST API or how you want, and then there is an utility that allows you to export a TOSCA recipe from that. So if you're not a fan of writing big YAML file, this could be a way to go. And thanks. If you have any question, I hope that my colleagues come back to help me answer them.
Questions for any of the folks? For you, okay. So you mentioned early on that you use Django for creating the data model for the service dependency graph. But later you described TOSCA. So I guess Django is the web framework that can be exported to TOSCA, or were those two different data models and service dependency graphs you're talking about?
So the data model is defined in Django, and you can use TOSCA to load data inside the data model.
So TOSCA runs on top of the REST API. It's a way of giving a specification in a TOSCA file rather than doing a sequence. It's a recipe instead of a sequence of API calls. Internally, the data model's in Django. Okay, actually. So that, for example, in OpenCORD, we are looking at TOSCA as the way you deploy not only the application, right, as services as you described it, right, but also potentially the infrastructure itself. So I think I heard earlier that it was a role for TOSCA, or actually maybe TOSCA or something, I'm not quite sure, in defining the pod structure, right? So maybe that's an offline discussion. It seems like a little bit more.
We use TOSCA to bootstrap the system. So we have part of the onboarding step is the services each have a little bit of TOSCA that they use to get themselves started, and yeah.
You mentioned about test capabilities and automatic testing stuff, and you mentioned about having some of that as being deployable on its own. Do you mean having it kind of as a VNF, actually just kind of create feedback back into the core system?
Where's David?
I think, yeah, question for David.
Can you repeat the question, sorry?
It might have been an earlier session, I think.
No, it was this one.
Yeah, testing suite, I think, for
Testing is a service, as a VNF.
What about it?
David said that he wanted to get
Yes.
to that point.
Yes, the idea ultimately is that the testing environment that we have Oh, this thing is horrible. The testing environment that we have, that we're currently building out, the idea is that it becomes also a VNF inside of CORD, even while CORD is deployed, to verify whether everything is working correctly. Yeah, yeah. I mean, that's the idea. Usually, when you have a data center environment, the test you have for the building block become functional, become verification that everything is working ultimately, because you need that feedback, right? You need that feedback. If you want to make sure that anything is working, you need the right hooks to be able to verify that it is working.
So is there going to be a standardized VNF that you're going to be able to offer for activity so that anyone else can basically use VNF all to do their own?
That's right.
Yeah,
So
yeah.
there could be many of them. In fact, analytics for CORD, ACORD, has gotten a little shortchanged because it's not residential, mobile, or enterprise. ACORD turns out to be a platform issue. And in terms of pitching for breakout sessions, the platform session is the one that's going to have a presentation about the roadmap for ACORD. There is a version of a monitoring service, which is part of ACORD, that's there now. But we're seeing a lot of different proposals, including active testing, which we have a little tiny reference implementation of we call virtual truck roll, that you can do diagnostics in real time. Active testing would broaden that. Active testing is this far from what we're just now talking about. So we expect to see, a set of services, an ecosystem of services, all touching different parts of the system, and this would be one of them.
That would be awesome. And I'm thinking more or less in a carrier situation, you have things like first field applications that are small, kind of real time.
Yep.
Very limited testing.
Exactly. You turn them on when you're trying to debug something. Yeah. Yep. Everything's a service.
A follow-on to that question. So you said you're going to have eventually a VNF or whatever, running tests. Is that going to cover both the infrastructure and the control plane? Or is right now it sounds like it's just testing the infrastructure to make sure that the services are working?
It would be fairly trivial to do that because of if we can just automate API calls into the thing and then see.
One of the test things that's it depends on where you put your probes. One of the things being measured or metered or probed right now is part of the infrastructure. So if you go back to a Ceilometer-like solution, and that's a piece of what's in there right now, all of the head nodes feeding stats into Ceilometer, that's infrastructure.
Well,
I'm sorry, service infrastructure. It's control infrastructure.
Orchestrate a new service as a test, for example, on the platform, right? You have to have access to the control plane APIs, right?
Yep.
Which typically applications wouldn't, right? Et cetera. So,
Well, yeah, except an application could come in through the northbound interface and say, I want to channel onto this particular service and recurse. Was it time to?
Yeah, we're going to take care of some logistics and then we're going to stop.
All right.
Okay.
Thank you.
So thank you, everyone. Okay.